Hello and welcome back. I am getting ready to go over our favorite kind of homework, TUMs. I know that we have not had homework for a while, so I just want to get y'all back in the swing of things, and I want to go over as many questions as possible. This is Unit 11, and we're going to get right into it based off of our notes from class today and our practice questions. So this is TUMs. Pages 115 to, I believe, 126, like we normally do. 115. Oh, wait a minute. It should be, I went too far. We need to start at page 111. 111 to 116, and then we skip the activities. And then the due date is whatever due date was discussed in class. If you're not sure of it, please check the agenda, and also please check the video from class. So this is unit number 11, and we're talking about probability. My name is probability. All right, so it says Miguel tosses a coin 3 times. The list represents the sample space of the tosses. We can get heads 3 times, we can get heads twice and tails once, we can get heads, tails, tails, we can get heads, tails, heads, we can get tails 3 times, we can get tails, tails, heads, we can get tails, heads, heads, or we can get tails, heads, tails. So looking at the diagrams, I need to see the proper sample space demonstration here in a tree diagram. So I need to have heads and tails first. So this has a heads and a tails first. This does not. This only has a heads. I need a tails over here, so this is incorrect. Then this has a heads and a tails. Then this has a heads and a tails as well. So now I need to see what the letters show me. I need 3 H's and then 2 H's and a T. So here I have 3 H's, so this is H, H, H. But then if I go here and here and here, kind of make a V, that's also H, 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 which is incorrect. So I need to make a list from the tree diagrams that are given to me to make sure that they match this list that's provided here. So if I look at these, I get heads, and then I can get heads and tails, and I can get heads and tails, and heads and tails again. Or here I can get tails, and then I can get heads and tails, heads and tails, heads and tails. This looks like it's about right. We'll get rid of this one because that's wrong. And then here I get heads or tails. Then I can get heads and tails, heads and tails. But then this says heads, heads, tails, tails. And then this says heads, heads, tails, tails. I'll leave it up to you to determine which one is the best of these two, C and D. The list shows all the possible outcomes for which experiment. Well, if we're talking about heads and tails, which is what we just did up here, what was the activity that was done and how many times? So this is 1 outcome and this is 2 outcomes. Up here, this was 3 outcomes. 1, 2, 3. So think about that when you're answering this question. Number 3, Andy's little brother has a toy box that contains 2 blue race cars, 1 green race car, and 1 red race car. Andy removes 2 race cars from the toy box without looking. If Andy removes a blue car first and does not replace it, which best represents the sample space for the cars Andy removes? Well, if he already has 2 blue, so I can say blue first, and then I can also say blue again because there's 2 blue cars. So that's 1 set. Then I'm going to get a blue car first as well, and then I can get a green car. Then I can get a blue, and then I can get a red. Can I get a red and a red? No, because there's only 1 red. Can I get a green and a green? No, because there's only 1 green. Furthermore, it says that he removes a blue car first, so that has to go first. Number 4, Nadia has 2 pairs of jeans, 1 pair of khakis, and 2 pairs of black pants she wears to school. She also has 2 red shirts, 2 white shirts, and 1 gray shirt from which to choose. Nadia wears jeans and a gray shirt on Monday. If she does not wear a clothing item more than once during a week, which list represents the sample space for Nadia's outfit on Tuesday? So she already wore jeans and a gray shirt. How many gray shirts does she have? 1. So she cannot repeat her gray shirt. But how many jeans does she have? 2. So I've already used 1 pair of jeans. So I can do jeans. I can do khakis. And I can do black pants. And with the jeans, I could wear a red or a white shirt, red or white. With the khakis, I could wear a red or a white shirt. And with the black pants, I can wear a red or a white shirt. So I need to find out how many different options I have, which looks like 2, 4, 6. And then I need to figure out what's up here that's offered to me. So let's see here. Jeans in red, jeans in white, jeans in gray. Can she wear jeans in gray again? Nope, because she already wore it on Monday. So this is wrong. Wherever I see jeans in gray, I need to cancel it out. Wherever I see gray, I need to cancel it out because she only has 1 gray shirt. So then I'm left with these 2 and I need to have 6 outcomes. Where'd you get 6 outcomes from, Miss Starling? 1, 2, 3, 4, 5, 6 ends in my tree diagram. Find the best answer from H or J. Next page, page 112. Sarah draws a card from a standard deck. You gotta get to know a deck of cards here. If the card is red and she rolls a standard die, if the card is red, she rolls a standard die. If the card is black, she flips a coin. Which of the following tree diagrams correctly displays the sample space for Sarah's experiment? Okay, if her card is red, then she could roll a standard die. And on a standard die, we've got numbers 1 through 6. If the card is black, she flips a coin. And we've got heads or tails. So you've got to look at which matches red and 1 through 6, or heads or tails for black. Number 2, Amelia receives a treat bag. The treat bag contains 10 gumballs, 5 pixie sticks, 2 bracelets, and 3 chocolates. If Amelia selects 3 items from her treat bag without looking and gives them to her sister, which could not represent a possible outcome for the items Amelia selects. All right. So I've got 10 gumballs, 5 pixie sticks, 2 bracelets, 3 chocolates, and she's getting 3 things. Can I get 3 bracelets? No, I cannot. So there's only 2 bracelets. Only 2. Can I get 3 gumballs? Yes, because there's more than 3. Can I get 3 pixie sticks? Absolutely. And can I get 3 chocolates? Absolutely. So I'm going to look through here and find out which one is impossible because of the number of things that I have. Number 3, a yogurt shop has a half-price mystery scoop special. The scoop could have vanilla or chocolate yogurt. It would also include either hot fudge, caramel, or marshmallow topping. Which list shows all the possible outcomes of mystery scoop special? So, vanilla or chocolate, and either hot fudge, caramel, or marshmallow. So come down here and make a tree diagram. Vanilla and chocolate. Okay, that's the first one that they give me. Then I need to include the 3 toppings. Hot fudge, caramel, marshmallow. Hot fudge, caramel, marshmallow. Hot fudge, caramel, marshmallow. If I count these, 4, 5, I have 6 outcomes. There's only one answer there that shows that I have 6 combinations. A vanilla and hot fudge, a chocolate and hot fudge, a vanilla and caramel, a chocolate and caramel, and a vanilla and marshmallow, and a chocolate and marshmallow. Good luck finding it. On to page 115. This is the last part. Leroy knows he will make an A, B, C, or D in his English class. If he makes an A or B, his parents will give him a choice of his favorite video game or cash. A or B, video game or cash. So if he makes an A, he can get a video game or cash. If he makes a B, he can get a video game or cash. If he makes a C or D, he will have to either complete an extra credit assignment for the class or work with a tutor to review the material. So if he makes a C, he can do extra credit or tutor. If he makes a D, he could do extra credit or he could tutor. Find the answer that best works.